So we'll begin with a few key concepts before looking at the program. But here we'll begin with two built-in functions, just like print. We have type and len. Now, there's a bunch of types of data, which are called data types. So we have integers, floats, we have strings, we have we have lists, we have booleans, and a bunch more. Now, each of these are their own data type. All that means is that if you were to identify what kind of value you are storing, it would be one of these. Now, the type function works like this. Type function. Now, the type function works just the same as any other function. It's always the name. So here it's type. And of course, in brackets, the value. Now, its behavior does not matter to you. You just know that it will always give you the data type of the value. I will say returns the data type of the, you can call it the input or the value. We'll say the input value. The input value. And the len function, we'll say len function, is specific to a few, and that'll be lists. And now a list we know is a collection of data, and this can come in the form of list of numbers. We'll say 1, 2, 3, 4. It can be strings. So hello, goodbye, okay. These are all strings, which we know by the quotations. It could also be boolean, so true, false, false, and of course these can go on as long as you need them to. And as many types of values. Now what the len function does is it returns, so given the length function, len, and then the value, which would be, we'll say the list actually. It doesn't take any value, it takes type of list. And then returns the number of items in the list. So here we have 4 items. 1, 2, 3, 4. It will return 4. Here we have 1, 2, 3 items, so 3. Again, 3. Now, one use case you wouldn't fully expect is if you have the len of some string. Returns the number of characters, which we'll denote as chars for short. And why is that? Well, we know that if we have, let's say, the string hello, hello, this is the same as if you had an individual character, H, then you had E, then you had L, then you had L, then you had O. So a string in itself is a list of characters. So if you give len a string or a list, and it will give you the number of items or characters within that value. Now there's 2 other more technical types or technical topics before going to the program. So we'll begin with the simpler one, or the console. Alright, so the console is a main dashboard in every development environment that allows the user and the programmer, or the programmer and the program to communicate. So through this, you can log various messages, status updates, or any sort of input asking. This all happens in the console. So if you ever have a print function or an input function, this all happens within the console. It's a very kind of simple way of communicating, let's say, the status of a program, or the method through which a program will continue. Because with input, you can decide the behavior, of a function, And this is we'll give an example. You can do other things with print. For example, you can give status updates. Now, the 2 more complicated topics are variable storage and escape characters. Now, escape characters are another type of built-in character in Python. It exists in other programming languages, but they might look different. In Python, these are the main few that you should know. Now, escape character, you can always recognize by the backward slash. It always begins with backward slash. Now, what an escape character is this set of special characters that do special functions when printing. So these go with the print function. Now, of course, they always begin with a slash, and they're followed by a character. We'll say char. Now, immediately, Python interprets the backslash and the char as one character. Now, let's say you have, hello. This is 1, 2, 3, 4, 5 characters. Now here, you would think this is one character, this is another character, but in Python, it interprets this entire thing as one character. Now, let's say you had a string where you want quotes. You'll say, you want quotes, hey, buddy. Now for this might give you, let's say, double quotes. This might give you an error because Python doesn't know where your quotations start and end. It reads from left to right. It'll say, okay, so this first quotation is telling me that the program wants to make a string. Oh, look at that. They want to end the string. Then we have this kind of leftover bit. Then we're saying Python, make another string, and then end it. So here, we've created one string that's empty, another string that stores buddy. But what happens here? This is left alone, and it will give you an error. So if you actually have quotes in your string, you put a backward slash. Here, Python recognizes that the character after the backward slash is part of the string. So here, Python is interpreting this as one character, and this is another character. So if you were to say print this, if you were to print this string, you would just get back, hey, buddy. Because Python interprets the backslash and the quotation as one character, but doesn't print it. However, a use case of this is that you can not just use it for slash, but any sort of character. But it's mainly for slashes and quotations so that you can have kind of more formatted status updates that are more grammatically correct for the user. Now, this can be followed by any character. However, there are some already built in escape keys, besides the kind of use case that you can have formatted strings. Here we have a few. The main ones you should focus on is backspace, new line, and T. These three would be your most used. Horizontal tab is the same as the tab key on your keyboard. It gives an indentation. So we'll say indent. The new line provides a new line, really. It moves the string to a new, we'll say, layer. So it indents if it was writing, dot dot dot, some string, and then you do slash backslash n, and then some more string. If you were to print this out, you get that string and then a new line of the new string. Backspace uses the cursor or the actual writing pointer. So it writes from left to right. So the pointer or the cursor moves from left to right. But then backspace kind of undoes one of those steps. That's really not that helpful. You can know it, but these two actually are your most important to know. And now finally, the most kind of technically dependent topic is variable storage. So we know that when we're creating a variable, we need a name followed by the equal sign and then some value. And now what's actually happening here in the background for the computer is that it's taking this name as the symbol. You can also call it a pointer. Now this pointer points towards not this value. It actually points towards the memory address. So every single time you make a new variable, you point towards an address within your memory. So let's say here we have the name of our variable. Actually, we'll do in blue. So let's say we have name value 1, and this value 1 has value of 0. So in a statement, this would look like value 1 is equal to 0. Now what's Python doing in the background is that it's saying that the symbol value 1 is being assigned to this memory address. Then this memory address is being assigned to this value. So really this is happening. That and then that. So this is where the updating occurs. So when you update the value, let's say in the next line, I say value 1 is equal to 2. We're now updating the pointer. So this here is now pointing towards something else. And this just disappears. So value is now pointing towards 2, or this new memory address. And this new memory address points towards 2. And now what we're trying to get at is that every single time you make a new variable, you create a new in the memory. And it has a new address, as you can see here. So your memory has specific addresses. And every single time you can make a new variable, each variable, the symbol acts as a pointer, pointing towards an address, and the address points towards a value. Now, this technical topic might not be helpful for low-level programs, but as you get more developed, so the idea, the main important topic is that you have two types of data. Data, we'll say subtypes, but that's technically not the best name. But you have both. Well, they're called mutable and immutable. What do those mean? Well, we know that in Python, when you create a new variable, the pointer now points towards a new memory address. That doesn't always work. So immutable refers to ints, strings. It also refers to floats. Now, why is that? Well, it's much better to point towards a new memory address with a new value in it than to change in place what the value holds. So what this means is that if I now change this value doesn't still point to this memory address, and then this memory address goes here. What happens is value goes to a new memory address, and this memory address holds a different value. Now, practically, what happens is if you have, let's say, var 1 is equal to 10, then you say var 1 is equal to 10 plus 1. This is not pointing towards the same memory, not same memory. This now is a new memory address. Let's say I went from here to here, and then it stores this new value in this value column. Now this is really simple because really all you're doing is changing one memory address to another. So you're changing one memory slot to another. Now this becomes a terrible idea when you have lists. So lists are a type of mutable function, or a mutable data type, in that if you have a list, let's say 1, 2, 3, 4, 5, ... You can generalize this saying that lists are always n numbers long. Now what happens if you have, n equals 100 items in the list? Well, what is that we have 100 unique memory addresses, and we like to shift all 100 to a random memory address. This is fine. Maybe 1,000 is also fine. A million or 10,000, 100,000, even maybe a million numbers is fine. But the second n goes towards infinity, or you have an insane amount of numbers, you might corrupt your entire memory by changing every single value. Because what happens is, once you change, so let's say again, we have value 1 set to memory location 1, and it points towards this. Then we change it, so now it goes towards here, and it corresponds towards this value. That's fine, but if you have 100 values, and these doesn't always go, just one shift down. It goes to random places in your memory, which is why it's called a random access memory. RAM. This is where the random portion comes in. The memory is then stored at a random location. It's not just shifted by one. Now what happens? You shift a million locations at random. That's when data corruption happens. So lists are known as mutable. Now again, what does that mean? Mutable just means unchanging, we'll say. Unchanging. So if the value cannot change, it is the storage or the memory address that changes. Mutable means that if I make a change, so let's say, for example, I have a list called equal to 1, 2, 3. Let's say I want to do LST1 is, say, 2, 3, 4. What happens is, when I do that, it's not, let's say this was an array. Sorry, we'll call it a list. This list is made of 3 parts. So 1, 2, 3. So the first part goes here. Let's say the second part goes here. Third part goes here. When I change them all, this does not mean individually they go to random places. So this goes here, maybe this goes here. That's terrible. What happens is all three of these are held in one memory location, and they all go towards their combined value. 1, 2, 3. So that's why lists are special. They hold all the values in one specific value, in the column value column. And when you make changes to it, this pointer, this variable, always points towards the same address. It's just the address and the value it points towards might change. Now, knowing all of this, we move on to the program. The program here has two strings, alpha and beta. Now we already know that these are two unique strings because they have different names. And then we want to print the type of alpha. We know that the quotations always tell us the string, regardless of single or double. Single and double are the same. They're both string, kind of string symbol, I guess. Now here, type alpha, this will print string because we're using this type function to return what type of value is stored in alpha. Now here, gamma is made 3 times. It's redundant. Now what does this mean? Well, if we have 3 different gammas, then of course there'll be 3 different values, or 3 different But what we learned here, the second you redefine a variable value, Python program does not read what the value is, especially for immutable types. Since we know that strings are immutable, since we redefine this variable every single time, gamma every single time, these are 3 different memory locations. 3 memory locations. Regardless of the fact that we have the same value in each one, it is the same memory, 3 different memory locations. Now here, we have delta. We print delta, give us this. But then here we have delta redefined, so of course it's a new value. We'll say new as well. We have an escape key. Now what happens here? Well, Python programmer, Python interpreter, since we're using single quotes, this single quote doesn't interrupt it. It doesn't say, oh yeah, we're beginning it here, ending it here. And then it's like, oh, what happened to the first or the other beginning of the string? It knows that this entire part is one character and that we want a formatted string using the / escape key. Same thing with epsilon. This time we're not using / to get rid of the quotes error. We're using /n, the new line escape key, as you can see here. So this, when printed, would give you up to here, then a new line, then up to here, and then a new line, and then up to here. So you have 3 lines of formatted text. Zeta would have you indent after every single letter. And here, give you a new line and an indentation. And the same goes for both of these. When you add them, of course, when you add 2 strings, the same way that operators in Python, if you have 1 plus 1, it gives you 2. When you're adding strings, Python says that, well, I'll just add the inside value. So let's say we want to do hello. This would give you the string hello world with no space, of course, because we didn't specify that. So when you're adding 2 strings, the operation add just combines or conjoins both strings. So if you print kappa, it'll give you the value for theta. So this value plus spacing in this string plus iota. Now here, the length. The length function, again, we know we're doing the length of a collection of items. Since a string is a collection of characters, this would return the length of theta plus this one blank space, so one character, plus the length of iota. Since here we directly give it a string, it'll just give the length of how many characters in this string. And a blank space is considered a character. Now length, since there's nothing in there, this string is empty, it's going to give you a length of 0. Now here, again, we know that the backslashes disregard the second symbol. So here, since we have a backslash, this is considered one character. So we do the length, or how many items this has, and since the string is a collection of characters, this would be 1, this would be 2, this would be 3, this would be 4, come together. This would be 5, and this would be 6. And now don't get confused here. This might get you, but Python, again, reads left to right. So if it reads like this, it would be, okay, this is 1, this is 2, oh, wait, we have a slash and then a slash. So this is 2. Then it says, okay, this is 3. Then, okay, we have a slash and a slash. So this is 4. Then 5, and then 6. Python does not say, well, I know that slash slash is something, and I also know slash t is something. So here, when it gets here, it doesn't, it correctly identifies that the escape key we want is slash slash instead of slash t, because it reads from left to right. So once it spots the backslash, it looks for the next character and sees whether it's one of the specially defined. And again, the same thing happens here. Slash slash. Now this lambda var stores 2525, which is of type integer. So this type call with lambda var as the input would give back integer. This would give back string.